Hello guys, welcome to Inside Electronics. So in today's episode, let's take a look at an ultracell renew nickel cadmium nickel metal hydride battery charger. I mean, this is the second time I'm making this particular video. Like, you are now watching a completely fine working product, and that is because I was a complete idiot and I accidentally deleted the two parts that was actually meant to show you guys. I was actually making a video about this one, and it was a three-part video. In the first part, I was actually making a teardown of it because this thing was not working, and I did a complete teardown and explained how it worked on the first part. On the second part, I repaired it. I replaced the faulty component, which was this IC right here. I don't know whether you can see that. And on the last part, I tested it for the first time in front of the camera, hoping for an explosion. And for some reasons, I accidentally deleted the first two parts, which means I lost the complete teardown part, and also I lost this repairing the troubleshooting part. I tried using some recovery softwares, but all I got was some corrupted file. I got the file, but it was corrupted that I cannot use it any longer. So now I have to make a complete new video. But at the end of this video, I will be joining the last bit that was recorded last time. So yeah, that was the mistake that I made. At the moment this thing works, but when I was actually making the video, this thing was not working. So let me talk about it, and I hope this video will not get deleted. So this thing is actually a battery charger. As you can see, I am using it to charge my eneloop batteries, and it is an ultracell renew charger. I bought it 5 or 6 years ago for 1,000 rupees. It came with 4 batteries also, but at the moment I'm using it to charge my Panasonic eneloop Pro batteries, and it does a really nice job. And the issue that I'm having is completely solved, and it was the second time that the issue is happening to this charger in a 7 year time. And the model number is 1200C, and it charges 2 or 4 AA or AAA, and the AA it charges at 400 milliamps, and for AAA it uses 200 milliamps, and also it has an USB input, and you can charge your battery by a USB power supply, and also by using AC mains. So it has 2 LEDs to indicate the charge state. It turns on continuously, and it will turn off once the battery is fully charged or the circuit is disconnected. And yeah, that's basically it. Has a built-in timer for 8 hours, so irrespective of whether your battery is fully charged or not, it will turn off this thing. Not the entire thing, but just it disconnects the battery from the SMPS. That's all it does after 8 hours. So enough of talking, let's open it. And opening this thing is a really tedious job because these has to come off, and it uses some clips over here. So let me open it and I will be back. So guys, I now have completely taken apart the cover, and let's take a look at what's inside second time. Okay, so I did an entire explanation of this once again. I'm going to do it, and I've been through all the datasheet and everything on the first section, but that actually gave me an advantage. Now I don't have to pause every time to look for datasheet and things like that. You can see the terrible soldering job that I did. In fact, the tracks came off from this thing due to the heat. In fact, this thing is showing its age. It is not that great, Anyways, this thing works. That's all I care about at the moment. In fact, I can use it. That's all it matters. So it has 2 separate sections. The top side is the SMPS, as you can obviously see, and this is what the complaint was. Right now I'm using the Viper 22A, and this was the faulty component. This is a Viper 12A. This is a 1 amp capable IC, and this thing is a 2 amp capable IC, so I upgraded it some in a sense. So basically it has two sections, the three sections, as you can see, as it is mentioned, it is a timer. So it has three sections. It has the SMPS, that is the main power source. It is a really common and really simple power supply based on a very popular IC, the Viper, and it uses double insulated transformer. As you can see, the wires are double insulated, so that is really good. In fact, there is no SMD component at all on the SMPS side. You can see the separation between the AC and the DC, the high voltage and low voltage side. There is a lot of separation. There is, I think, more than enough separation is there, and there are anti-tracking slots over there. So that really is a really good job, in fact. And as I mentioned, it has the USB input also, so it can charge the batteries from either AC or a charger. A mobile, an old charger will do the trick. It's a type B plug. So that's the first section, the charger. The second is the charger, the charging section itself. This is the power supply. This is where the charging is happening. And the third thing is a timer IC that is over here. So there are two transistors over here, which is what the timer IC makes use of for disconnecting the battery from the SMPS. In fact, the working is really simple. If you look closely, you can see the AC mains gets rectified to DC, and you can take the output from this point over here. This is where the output, so this is where the output is. This is the ground, this is the output. And if you look closely, you can see something really surprising. The output from the diode is connected straight to the USB also. There is no protection at all. So what that means is that if you plug in something that can draw power from a USB port, and if you plugged in this thing, then you can basically power the other device, the USB device, from this itself, because the diode will pump out 5 volts to the USB port. So whatever device you plug it here, basically the device you are going to plug it here is going to be a charger. But for some reason, if you decided to go on with something else that has the USB type B plug on attached to it, so it can draw power from the power supply itself. It is actually good and bad in some senses. It is good because we can take out power from this side if we need, and it is bad because it can damage some critical electronics at some point. So that is a really bad design flaw. There should be a diode here to protect the power going from this side to the USB to prevent backfeeding. And after that, it is all really simple. It may look complicated because of all the SMD components in here, but it is basically nothing. The IC is an HCF4060. Let me focus on it. It is an HCF4060, which is actually a timer IC. It is actually a timer that can also be configured as an oscillator, but in this case it is using as a timer. Oops, there was my camera. Let me adjust it again. Okay, I think that is enough. Okay, so that's an HCF4060 IC over there. So what is happening? It is really simple. In fact, the AC mains comes in, and these resistors are the current limiting resistor. It says 400 milliamps and 200 milliamps, but these resistors are what decides the charging current. In fact, if you take a look, you can see the AC mains, the positive side coming from here, let me focus on it, is going straight to the track over here, and from there it is divided into two sections, and that is where the transistors came into action. It has a built-in timer. Okay, so under normal circumstances, when the device is plugged in, the timer resets and it starts counting from 0, and up until the time has reached 8 hours. If the time is below 8 hours, the output of the timer remains low, and a low output at the timer is fed to the base of the transistors. So the transistors will not kick into action, and it passes the supply that is coming from here, and it takes the supply from here, goes to here, and these heavy solder tabs are the battery positives. As you can see over here, those four are the battery positives. So when the output of this thing is low, it actually initiates the transistor. It's a PNP transistor, so it initiates the transistors. Depending on the number of batteries that you connected here, either one of them or both of them will turn on. And when the device is turned on, when the transistor is turned on, the collector, the circuit gets the power from here to the other side via the transistor. So that's how it activates the circuit, and because of that, it needs two batteries in series. If you take a look, you can see this is the negative of first battery, this is the positive of that. It is connected straight from here to the negative of second battery, so it is a series connection. Okay, so it needs two battery to initiate. You cannot charge a single battery. You can charge either 4 batteries or you can charge 2 batteries. You cannot charge a single battery. That is because of this arrangement. And the way it detects the battery is fully charged or not is really simple, because all it has is an LED. You can see the 2 LEDs which are used for charge indicators. So basically, if the battery is fully charged, they will be turned off, and when the battery is not fully charged or the battery is charging, it will be lighting up, and that is detected by the resistors over here. When the battery, these resistors are voltage droppers, so the values of these are chosen in a way that only when the battery voltage reaches the full charge level, the voltage across this resistor will be 0.6 volts, so that it activates the transistor and the negative of the LED gets pulled to ground. And on other side, when the battery is charging and not reach its full charge value, the voltage drop across this will be low, so the transistor won't turn on, and that will make the LED light up. And once it has reached the threshold voltage, it will stop the transistor and thereby turning the LED off, which indicates us the charging has stopped. And the same circuit is duplicated on the other side. It is a mirror copy of each other. So that's it. That's basically it. This particular IC uses the capacitor for its time calibration, for its time limit setting, and it's a 16-pin IC, but only 8 of them are used, and this IC only needs a very few supporting components, especially this is a timing capacitor and very few supporting components. And yeah, that's it. And what they could have done in a better sense is that instead of turning the LED on and off, they could actually redesign the transistor so that it activates this transistor and it will turn off the entire circuit once this is fully charged. Now at the moment, this thing does not have such a feature. It will only turn it will disconnect the battery only after this thing has reached 8 hours. If the battery is fully charged before the 8-hour time period, only the LED will turn off, indicating that the battery has now fully charged and it is now time to take the battery out. So what they could have done is they can rewire the transistor so that it activates this transistor, thereby disconnecting the entire circuit once the batteries are fully charged. That is one thing that they could have done. But anyways, I hope everything is explained, and yeah, basically that's it. Thanks for watching. See you in another video. Okay guys, so I now have completely replaced the IC. As you can see, it is now Viper 2.2a at the moment, but I made a completely terrible job because I accidentally taken out the track for the IC, and I am currently using kind of wire and stuff to actually do it. So I haven't turned it on yet. I have tested for continuity between these everything, so I ensure that there is no short circuit or anything, but still I'm going to turn it on in front of the camera for the first time, and let's see what's gonna happen. I'm going to turn it on at 3, 2, 1. Okay, that is a good sign. It is now turned on, and I'm seeing no smoke or anything, so I assume that it is working at the moment. There is only one way to test it, that is to actually place a battery in, and let's turn it on then. So I'm going to unplug it. Let me use some batteries to actually test it. So by the way, I have completely explained by now how this thing works, and you now have seen how this thing works internally. So it's only a matter of putting everything in. Let me adjust the angle of these things so the battery will stay. Okay, let me do it and I'll be back. So guys, I now have plugged in 2 batteries. So if I plug this in, it should, the LED should light up. So let me turn off the lights, and as you can see, something is, yes, it has detected, and the LED is now on, which means this thing is back in action. So let me try it with the other batteries, and I'll be back. So here is it with full 4 batteries, and I'm going to turn it on now. And there it is now, both the LEDs are now on, which means it is working, and I made it working back again. That is a relief, because I expected something to blow up, and I know you guys were also wishing for that. But anyways, nothing has happened. And by the way, that is about the ultracell renew rechargeable battery charger. So I hope you understood everything about it. The build quality is okay, except the soldering job that I did right now. Everything else is working fine. So yeah, that's it. That's for today's video. Thanks for watching. See you in another video.